let's discuss one simple problem based on the condition and the order we need to write for the congruency. Let's start. If AB is equal to QR, so first condition it's given over here that AB is equal to QR. Another is BC is equal to PR. So BC is equal to PR. And another is given CA is equal to PQ. CA is equal to PQ. Then what will be the condition for the congruency? Basically, we need to write that triangle, let's say ABC, congruence triangle dash. Basically, this is what we need to write. Okay. You can keep the order on any one of the side, like PQR over here and ABC over here. That will also work out. So let's start. Now A is over here, right? So QR is there. First of all, we want to identify A goes with which alphabet, right? So A, okay, here that is. Where is the another A, right? A is over here and A is over here. So which is the common alphabet over here? See, here QR is there and PQ is there. So A is common here. So Q is common on that side. So we can write A goes with Q. Right, this is very simple thing we need to understand. A is over here, so Q is also at the same time. A is over here and Q as well. Nice. Now let's talk about BC. BC over here, right? So and here AB is there and BC is there. So see, B and B is common in both of them. So which alphabet is common in both of them? See, R is over here and so over here. So Q, R, and finally what's left? P over here, right? So see, alphabetical order is always, it's not mandatory to maintain when we write the congruency, right? ABC over here and here QRP. So break that myth that in the case of triangle, we are always going to have alphabetical orders, right? It is possible one time you write it for one side, then another you need to follow the condition. If you write over here that PQR, that's absolutely wrong, right? It's not going to work out. So that's why order is very, very important. You need to maintain the order that A goes with Q over here. And this is very simple logic, right? You just need to find out the common. A is common over here, so Q is there. B is common over here, so R is there. Two alphabet are done. Whatever left will be going with the C. So this is why this sum is only talks about the importance of the order that you need to write, you need to maintain while you write the condition for the congruency. Now we are going to discuss what are the conditions that we need to prove two triangles congruent. So we discuss to prove two triangles congruent, we need to prove 6 conditions, right? Total 6 conditions we need to prove that. 3 sides and 3 angles. Now, is there any shortcut way to avoid proving every time 6 conditions? Yes, there is, right? We are not supposed to always need to prove 6 conditions to prove that two triangles congruent, right? So there is a way to do that. Now we are going to discuss. There are 5 conditions. Either you prove 6 conditions or either you prove any one condition out of the 5 conditions that we are going to discuss in this session. So first of all, let's start with the SSS. You must be confused, right? What is SSS is about? Remember, basically 2 initials that we are going to use, S and A. S for the side and A for the angles, right? So when we say SSS, right, it means that side, side and side. Okay, remember side, side, side. If we talk about SAS, it is side, angle and side. So rather than proving all the 6 conditions, if I prove that 3 sides of these 2 triangles are equal, then I can say that these 2 triangles are equal. Very simple, right? SSS means side, side and side. That's what I need to prove. Let's mention here side, side and side. This is what we need to prove it. If we prove 3 sides of triangle equal, we can write that these 2 triangles are congruent. Very simple it is. Let's start. So x Y and Z, here A, B and C. So let's say XY and AB equal YZ and BC and XZ and AC. So if we just prove over here that XY is equal to AB, then YZ is equal to BC, and finally ZX is equal to CA. If we prove this, then our sum is done, right? We can write by SSS criterion we can write that triangle ABC or XYZ similar triangle ABC, right? Very simple it is, right? This condition is very simple, right? You have three sides given equal, then you just need to mention that which side goes with which side, like XY is equal to AB, YZ is equal to BC and ZX is equal to CA. So by SSS criterion we can mention that this triangle similar this triangle. Again, order matters a lot, you can check it as well. The order I have written is correct. So this is the first condition to avoid proving six conditions, right? If you prove side of two triangles equal, your work is done. Let's discuss the next condition. Next condition is SAS. Now think of this kind of name, like extended version of it. So as S is for the side and A is for what I told you at the start only, that is for angles. So let's write this condition is about side, then angle and side. Now here order matters a lot. How? Let's say I'm just taking two triangle, let's say M, N, O and P, Q and R. Okay, side, angle, side. Now this angle should be included. Very important word, included. This is included angle. Included angle means what? That this side is equal and this side is equal. Between them there should be this angle, right? It cannot be anywhere else. Remember, this is very important condition. Let's say I want to explain that. So let's say if I MN and PQ is equal and another MNO and QR is equal. So now we are done with the two sides, right? And if you observe between these two sides there is angle. This angle is called as included angle, which is between these two given sides only, which is between these two equal sides if we want to specify it, right? So this angle should be equal without any doubt. Remember, then only we can follow this condition. Very important. Students do get confused that can I take any other angle? No, you cannot take it. We cannot say that angle M is equal. No, that is not possible. That will not be considered as SAS criterion. Remember, so two sides are equal and between them this angle should be lying. Then only we can say that included angle. That is the condition for included angle. And then only we can apply this SAS rule or criterion. So let's mention it. First, it should be what? Side, right? So MN is equal to what? PQ, right? That is our side. Then let's write angle N is equal to angle Q, that is our angle. And one more side, and O is equal to here QR, that is side as well, right? So we have one side, angle and side. So between these two sides this angle should be lying, means it should be included angle. Very important condition. So let's write the congruency criteria. We have triangle M and O congruent triangle. Let's see, M goes with N goes with Q, that we know very well, right? So if there are here N is there, so Q should be over here. M goes with P, Q and R. Very simple. I have just taken for the understanding to avoid any confusion in the alphabetical order only, right? It is possible that in exam you actually need to think that what can be the order, right? So these are the two criteria. First of all, if you want to just understand, I just write on the triangle side, 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 and for this SAS, very simple, to any two side you can take it, angle, side, any two side you can take it. It's not compulsory that these two sides, here it is possible these two sides are also equal to this two side, and angle M can be included to angle P. That is also possible, right? So when we'll discuss this sum, you'll have better idea. So let's recall these two conditions. First of all, SSS, S means side. So side, side, side. Three sides of this triangle and three sides of this triangle are equal. So we can say these two triangles are congruent. Next condition, next rule or criterion, SAS. S is for the side and A is for the angle. So side, angle, side. That is the condition. And this angle should be what? Included. Included means between these two equal sides, right? So this is how we are supposed to write, and this is how we can mention that these two triangles are congruent. So these are the first two conditions. Let's discuss the other conditions. Let's discuss other two criterions. We discussed first two, that is SSS, side, side, side. Another was SAS, side, angle, side, and angle was included angle. So similar to SAS, we have ASA. Now guess what? A is for angle, S is for side. So if we want to write the name of it, that is angle, side, angle, right? Very simple. Here also the same condition. What same? Included one. That side should be included. Side should be included. In what way? Let's take two triangles. Again here X, Y, Z, and here let's say P, Q, and R. Angle, side, angle. We need to have how many angles? Two and one side. So let's take any two angles. Let's talk about these two angles. Let's say I have X and here P, here Z, and here R. So two angles are done. Now if I want the included side, which is between these two angles, then what side shall I select? Compulsorily, that is the only condition. So XY here, right? And another we need to take, which is included side. Included side between angle P and angle R is what? PR, right? So these two sides should be equal compulsorily. Then only we can follow this criterion, angle, side, angle. So let's mention that angle X is equal to angle P. So angle X is equal to angle P, that is angle, right? Another, let's write, always try to write in the order ASA, then side XZ is equal to here PR, that is side, then angle Z is equal to angle R, so that is angle. So ASA. So we can write triangle XYZ congruent. Let's see, we have here X with P and Z with R. So here PQR, basically same order. I've followed the same order, nothing, alphabetical order basically, right? So what is this about? ASA, angle, side, angle. You need to have two angles and the included side, which is between that, between those two angles. So this is what we can prove it. Now next come to the angle side. Okay, think of it, what it should be. A stands for angle, side for the S for the side. So angle and side. Okay, now are we going to consider the included part over here? No, absolutely not. It's not about included angle or included side here. So how it can be? Let's name it X let's start A, B and C, here M, N and O. So we have two triangles. First of all, let's take two angles. Two angles can be anywhere. So first of all, let's take angle A equal to angle M. Then angle B is equal to, let's say, angle N. That is being done. So two angles are very easy to take it. Now what about this side? Where should be this side? Then only this criterion can be applied. So this side can be in contact with either of the angle, in contact with the either of this angle. Now if we take AB is equal to MN, then which criterion will it become? ASA only, because that will become included side. This is what we do not want. Remember that. We are not going to take this AB is equal to MN. That will be ASA criterion, right? So we need to take either AC or either BC. That will work out. Remember, right? You can take AC or BC as the side. So what we do conclude from here as well, you take two angles and the side will be in touch with any of the angle or either of the angle. Let's say it is in contact with AC. So here let's say MN, right? This is all AAS is about. So you can say A and S, right? If BC is equal to NO we take, then also we can follow AA and this S. So this side should be in contact with either of the angles. So let's write the condition here. So first of all, let's start with angle. So angle A is equal to angle M. Then another angle, let's mention it is angle. Then angle B is equal to angle N. That is also angle. And side we have AC is equal to MO. So what congruency condition we can write here? A, B, C, congruent triangle. A goes with M, B goes with N. So what's left? That is O. Very simple this is as well. Remember, you take any two angles and one side is in contact in either of the angle, like in this case BC or AC. That will work out. So these are the two conditions. ASA, let's just for the one we need to have angle, then side, angle, right? Between two angles there should be included side. And in this case you can have any condition, you take any two angles, right? And you can take this side or this side, let's say AAS, but order should be maintained. Don't write here ASA, that's incorrect, right? We need to have the included side. So these are the two more conditions, ASA and angle side. Now there is only one condition left, which is based on the right angle triangle. Let's discuss the last criterion to prove two triangles congruent, right? So this is RHS, right? You know the meaning of S, you don't know the meaning of H, or maybe you have an idea, it's good, or R. So this specific criterion is for right angle triangle. So R is for the right angle. Let's start. Right angle, then hypotenuse, and the last S is for side. So when we want to prove two right triangles congruent, we are going to follow RHS criterion. Okay, so for that let's name the triangle first of all. A, B, C, X, Y and Z. So for right triangle this is 90 degree. So we have one angle equal, basically that is right angle. That being done, now we want hypotenuse. Hypotenuse should be equal as well, and side. Now for the right angle triangle there are two sides. One is base, another is height. Either of them can be equal, or let's say only height is equal in this case, that is also accepted, or base is equal BC and YZ, that is also accepted. So let's take only base here. So BC is equal to YZ, right? So this is what RHS criterion is, R for right angle, H for hypotenuse, and BC is for the side. Or if you don't have BC, you can take AC as well. That depends on the given conditions. We cannot just take it. So let's write angle B is equal to angle Y. Let's write angle B is equal to angle Y is equal to 90 degree. That is our right angle hypotenuse, that is AC here, and XZ, that is hypotenuse, and side we have BC here and here YZ. So that is our side. That is our RHS criterion. Very simple it is. For right angle, whenever you see the right angle in the figure, try to prove with this criterion, right? If it's not possible, you can follow another one. So triangle ABC, congruent triangle, right? X, Y, Z. I'm keeping the same order for understanding of the criterion. So this is about the RHS criterion. So you need to have right angle, you have hypotenuse, and any of the sides. So we discussed 5 criteria, that is S, 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 A, S, A, S, A, S, and finally RHS. I told you the concept behind this 5 criteria is that we don't want to prove 6 conditions, 3 sides and 3 angles, but we want to prove only 3 conditions, right? So you need to follow any one of it to prove the 2 triangles congruent. Now let's do few questions based on this criteria.